All right, section 6.5, solving square root and radical equations. A radical equation is an equation that has a variable in a radicand or a variable with a rational exponent. If the radical has an index of 2, the equation is a square root equation. In this lesson, we'll assume that all radicals and expressions with rational exponents represent real numbers. So here it wants to know what is the solution to 3 plus the square root of 2x minus 3 equals 8. So we'll just go ahead and rewrite this real fast so we can start solving this. So the first step we want to do is we want to move this 3, because eventually we're going to have to get rid of that radical. So we'll subtract 3. We've got the square root of 2x minus 3 equals 5. To get rid of a radical, in this case the square root, we're going to multiply both sides of this equation. Sorry, we're not going to multiply. We're going to square both sides of this equation. So when we square the left, we're left with 2x minus 3 because they cancel out. And then on the right, 5 squared is 25. Now we'll just finish solving this. We'll add 3. We've got 2x equals 28. We'll divide by 2, and we're going to get x to equal 14. If we plug this back into this original equation, we should be able to check and see if it is actually the solution. So let's say 14 minus 3 equals 8. So we've got 3 plus the square root of 25 equals 8. 3 plus 5 equals 8. 8 equals 8. So it's we got a good answer there. We're good. All right, so let's try another one. It says, what is the solution to 4x plus 1 minus 5 equals 0? Square root of 4x plus 1 minus 5 equals 0. First thing, we're going to move the 5, so we'll add 5 to the other side. So the square root of 4x plus 1 equals 5. To get rid of the square root in this case, we're going to square both sides. So 4x plus 1 equals 25. We'll then subtract 1. We've got 4x equals 24, divide by 4. And in this case, x equals 6. So take note of the first statement. To solve equations of the form x to the m over n power equals k, you raise each side of the equation to the power n over m, or in this case, the reciprocal power. If either m or n is even, then you have to keep in mind that when you raise that value to the reciprocal, it's going to be the absolute value of that quantity. And so I'll show you what that means in this example here, because we have one. And so we're going to be looking to cancel these out by raising things to the reciprocal power. So let's look at this first one. It asks us to solve this equation. So we've got 3 times x plus 1 to the 2/3 power equals 12. So first thing we want to do is we want to get rid of this 3, so we'll divide. So we've got x plus 1 to the 2/3 power equals 4. All right, so now to get rid of that 2/3, we're going to raise both sides of this equation to the 3/2 power. All right, and so as we do this, keep in mind they said if one of the values of that fraction was even, we'd have to worry about, or we'd have to take the absolute value of that. So what they're saying is we're going to, instead of just getting rid of the parentheses and the exponents, we're going to be looking at the absolute value of x plus 1 equals, and then whatever 4 to the 3/2 power is. Well, in this case, 4 to the 3/2 power is just 8. Because of the presence of this absolute value, when we solved absolute value earlier in the year, remember we had to account for both the positive and negative aspects of what could be inside those bars, or what could be applying. So in this case, we should rewrite this problem as x plus 1 equals plus or minus 8 in order to get rid of the absolute value. So now we're just going to solve this. So we go up here, we've got x plus 1 equals positive 8, and x plus 1 equals negative 8. In both cases, we're going to subtract 1. And so one answer is x equals 7, and the other, x equals negative 9. And so this is something you have to account for when either the numerator or the denominator of your fractional exponent is even. All right, so we're looking at a very similar situation here. So let's say 3 to the 5th root of x plus 1 to the 3rd power plus 1 equals 25. What I want to do to start this problem is I want to turn this radical expression into an exponential one. So it's going to be 3, and then you've got x plus 1 to the 3/5 power, and then plus 1 equals 25. So let's get rid of the 1 here next. So we'll subtract 1. So we've got 3 x plus 1 to the 3/5 power equals 24. We'll divide by 3 because we want to get that quantity alone so we can get rid of that rational exponent. So we've got x plus 1 to the 3/5 power equals 8. So now what we can do is get rid of this by multiplying or raising both of these to the 5/3 power. We're using the reciprocal, so 5/3 power. And notice that neither 5 or 3 is even, so we don't have to worry about any of that absolute value stuff. So in this case, we're just going to get x plus 1 equals, in this case, 8 to the 5/3 power is just 32. And then we just want to finish solving this by subtracting 1. And so x in this case, subtracting 1, x equals 31. Here we're going to do the same thing we did in the first example, and we have to account for this even numerator in our exponent. All right, so pause the video, try this one on your own. I'll put the work up here, and when you're ready, unpause it and then take a look. All right, so here we want to make sure as we're solving this, we're dividing by 2 first, then we're raising both sides of this to the reciprocal power, so 3/2, and then because of the even value in the numerator, in this case the 2 there, we're going to have the absolute value of x plus 3 equals 8. To undo that absolute value, we know that we have to account for positive and negative 8. Then we solve both, and so x equals negative 11 and x equals 5. All right, so when we raise each side of an equation to a power, it is possible to introduce extraneous solutions. So therefore, it becomes very important for us to check our solutions in the original equation. In this case, an extraneous solution is a solution that we saw when we did everything right, we got the right answer, but it just doesn't work. All right, and so the correct solution will give us a true statement, and extraneous solution will give us a false statement. So here we have an example of one where I'm almost certain we're going to get an extraneous solution for. So now we just want to solve this. So in this case, we're going to start by adding 5 over here, and we're going to get the square root of x plus 7 equals x plus 5. So now to get rid of the square root here, we're going to square both sides of the equation. When we square this half, we're going to have to use FOIL. We're going to FOIL this out. All right, and so on the left, pretty easy, it's just x plus 7. On the right, we are essentially taking x plus 5 times x plus 5. So that would be x squared plus 5x plus 5x plus 25. Combined are like terms. So we've got x squared plus 10x plus 25. Well, now, in order to solve this, now that we're dealing with a quadratic, the goal would be to bring everything to one side. So we need to move the x and the 7 to the other side. And so we've got 0 equals x squared plus 9x, oops, and then plus 18. So in this case, I know x squared plus 9x plus 18 is factorable, so I'll factor this. It's going to be x plus 6, x plus 3. So my solutions in this case would be x equals negative 6 and x equals negative 3. But like I said before, we need to check for extraneous solutions. So what we would do is we would plug these back in. So we'll just plug them back into the original equation. So let's test them we'll use the color orange. So we've got the square root of negative 6 plus 7 minus 5 equals negative 6. Well, negative 6 plus 7, that's going to be 1. Square root of 1 is 1 minus 5. Well, this is going to be negative 4 equals negative 6. That's not true. So the negative 6 is extraneous, so let's look at the other one. So the square root of negative 3 plus 7 minus 5 equals negative 3. Negative 3 plus 7 is 4. Square root of 4 is 2. So you've got 2 minus 5 equals negative 3. So that's negative 3 equals negative 3. That's true, so that's a good solution. So in this case, negative 3 is solution. Negative 6 is extraneous. All right, so let's try another one real quick. So we've got the square root of 5x minus 1 plus 3 equals x. So square root of 5x minus 1 plus 3 equals x. We'll move the 3 by subtracting it. So we've got the square root of 5x minus 1 equals x minus 3. We're going to square both sides. So that's 5x minus 1 equals, in this case I'll just do the FOIL in my head, x squared minus 6x plus 9. We'll bring over the 5x and the 1, so subtract 5x, add 1, subtract 5x, add 1. So in this case we've got 0 equals x squared minus 11x plus 10. Two numbers that multiply together to be 10 but add to be negative 11, well, that's going to be x minus 10 and x minus 1, which in this case means our solutions are x equals 10, x equals 1, but we need to test. So for x equals 10, we'll try that one first. So we've got 5 times 10 minus 1 plus 3 equals 10. So this is 50 minus 1 is 49. The square root of 49 is 7. So 7 plus 3 equals 10. So 10 equals 10. That's good. Then we try for x equals 1. So we've got the square root of 5 times 1 minus 1 plus 3 equals 1. So 5 minus 1 is 4. Square root of 4 is 2. So 2 plus 3 equals 1. 5 does not equal 1. Okay, so that means 10 is our good solution, or the working solution, and 1 is extraneous. So here it talks about solving an equation with two radicals. And so we're going to approach this very similar to things we've done before, but we're going to have to raise it to a particular power twice. So in this case, let's just start from the beginning. 2x plus 1 minus the square root of x equals 1. Let's get just this quantity by itself, so we'll move the square root of x to the other side by adding it. So we've got the square root of 2x plus 1 equals 1 plus the square root of x. We could write this the other way, and I think I like it better that way, so let's write it this way. The square root of x plus 1, that's nicer. So now we're going to square both sides of this to see what happens. So we square this. This quantity here is going to have to be FOILed. So if we FOIL this out, we've got x plus 1, square root of x plus 1. That's going to give us x. Square root of x times x is just x. Then we've got plus square root of x plus the square root of x plus 1. Like terms in the middle give us x plus 2x, or square root of 2 square root of x, 2 square root of x plus 1. This side on the left, it just cancels out, so we've got 2x plus 1 equals x plus 2 square root of x plus 1. And now we're just going to try to get everything away from this new square root here. So we're going to move the x over, so we're going to subtract it. So we've got x plus 1 equals 2 square root of x plus 1. Subtract the 1. So x equals 2 square root of x. And so at this point, we can go ahead and square both sides of this. So we'll square this. We'll square this. So we've got x squared equals 4x in this case. Now what we want to do is because of the quadratic, we got to get set equal to 0. So we'll bring the 4x over. So x squared minus 4x equals 0. We're going to have to bring this up here. And so we should remember how to solve this particular type of problem because we should notice we have a GCF in both quantities. So we're going to factor out an x. We're left with x minus 4 equals 0. In this case, we're going to set each quantity equal to 0, so x equals 0. And here, x equals 4. Then we want to check our solutions. In this case, they both check out, so we're good. Here we want to do another problem, and so what I want you to do is pause the video, give this one a shot, see how far you get. If you need to, unpause it and check the work along the way. So this problem is particularly tricky. You're doing the same things. You're moving the square root of x over. You get x squared of 4x plus 4. Square both sides. Then you FOIL out the right. Then you have to bring everything to the other side, in this case, before you try to square the rest. So ideally, you're trying to get this part alone so you can do your squaring the second time. So when you bring over the x, you get 4x. When you bring over the 16, you get negative 12. You square that. You then have to FOIL out this part to get 16x squared minus 96x plus 144 equals 64x. Then you want to subtract over the 64x, and then you're left with this large quadratic. But notice that every term has a GCF, so you can pull out the 16 to make the numbers much smaller. Then you can factor this part. And so your factors of positive 9 that add to be negative 10 are negative 9 and negative 1. So your solutions are x equals 9 and x equals 1. But this time, when you test the x equals 1 in here, it ends up being extraneous. The x equals 9 works, but the x equals 1 is extraneous.